In this video, I want to talk about inverses and how you verify that you actually have two functions that are inverses of one another. So first of all, I think what you learned in pre-calc is kind of your way to find inverses is to start by, you have a function here, it's y equals 5x minus 1, and you learn to change the x and y, and then to solve for y. So add 1, divide by 5, and this then is the inverse. Okay, we notate it with a little -1 like that. So it's x plus 1 divided by 5. The reason you do that is because an inverse function says, or a function says we know what x is and we plug that in and get y. An inverse says now we know what y is, so we have to solve for x. So I always find it a little odd. Most books, tell you just switch these right away. I always think it makes more sense that, if the point of an inverse is you know what y is and you're solving for x, to say, well, I'm adding 1 dividing by 5. But a lot of books, say switch those right away. So this other one, of course, you'd have a y equals 5 over x. You'd swap the variables out, so you'd have the x equals 5 over y, cross multiply both sides, so you have xy equals 5, so y equals 5 over x. So your inverse is actually the same exact thing. Alright, now let me put a box around these two. These are our inverses. To verify that you actually have correctly found the inverse, you use this property that when you compose them, f of g of x, you get out x, and g of f of x, you get out x. Now what that means is if you have an x value and you perform the function, and then you perform the inverse, it should bring you back to the x function. That's, of course, what inverses are. They should undo each other and bring you back to where you started. So you plug x into g, you plug g into f. If f and g are inverses, you get x back out. So let me do that. Let me compose these two. Let me start by putting the inverse into the function. Okay, so I have 5 times x plus 1 over 5 minus 1. So I just put the inverse in to the function. Well, 5 multiplied by something over 5 divided by 5 is 1. So then I have x plus 1 minus 1, which is x. So you see I do in fact get out x. The other way, of course, is putting the function into the inverse. So we'd have 5x minus 1, plus 5x minus 1 plus 1 over 5, right? We're just putting the function into the inverse. Well, minus 1 plus 1 is 0. 5x divided by 5 is x. So you see that when I compose them, I get x out. So over here, if I put the inverse in, I have 5 over x. Well, dividing by a fraction is the same as multiplying by a reciprocal. So let me write this is the same as multiplying by x over 5. And 5 divided by 5 is x. I'm kind of running out of room, so I'll just kind of circle it. And if we compose the other way, of course, since they were the same, we get the exact same thing. So composing the function in the inverse, we also get x. Okay, so what we did here was we found the inverses. The simplest way, I guess, is rewrite it as a y equals, swap the variables and solve for y. And then we verified that we actually did find the inverse correctly by composing the function and the inverse in both orders. Okay, it's not necessarily commutative, so you got to actually check that. That both orders work. This box down here is going to be a key, and I hope you kind of look at this and say, well, we're talking about in calculus, we talk about derivatives. You think about a derivative here would require some chain rule. You know, you do the derivative of the outside, leave the inside alone, multiply by the derivative of the inside, and of course on the other side the derivative of x is 1. And that chain rule work on this kind of key property of inverses is what's going to help us figure out the derivative of inverses. Okay?